Hey students, this is lesson 9 for symmetry. We are going to learn how to find symmetry in a couple different ways. Rotational symmetry, symmetry with 3D objects, and other types of symmetry. Go ahead and do this page. You can check back with your answer.
Thank you.
All right, so here's your key concepts. Types of symmetry. A figure has line symmetry or reflectional symmetry if there is a reflection for which the figure is its own image. The line of reflection is also called a line of symmetry. It divides the figure into congruent halves. Go ahead and do 8, 9, and 10. You can check back with your answers. All right, identifying lines of symmetry. How many lines of symmetry does a rectangle have? Go ahead and pause here if you want to take a shot at it. I know one thing some students would do is they might think that this is a line of symmetry, but that would have to be an image onto itself, and I don't think it would be. So that is not included in the lines of symmetry. But there is one here because we could fold it in half that way, and there's one this way. So it looks to me like there's two lines of symmetry, a horizontal one and a vertical one. Go ahead, you can do this one. Check back with your answers. All right, identifying a rotational symmetry. Does the figure have rotational symmetry? If so, what is the angle of rotation? I think we should go back and just review that quick. What does it take to have rotational symmetry? And it's right here. A figure has rotational symmetry if there is a rotation of 180 degrees or less for which the figure is its own image. So we need less than 180 degrees or less to map back on itself. So if I take this figure here, and I'll just quick take a picture of it, and then we can get an idea about this a little bit better. So there's my image, and then all right, now I can rotate this. So I need to be able to rotate it less than 180 degrees and land on itself. And I can see that this one lands at a 90-degree rotation. So we're going to say yes, because we map back on itself with a 90-degree rotation. And we can see that by putting in these lines of symmetry here and seeing that we would land on a line of symmetry after a 90-degree angle. Okay, now this one here, this heart shape, if I put that on, if I take a picture of that, so there we are, and then I put that there, now I'm going to rotate that. I have rotated it. Now there's 180 degrees, and at no place in there did it land on top of itself. You can take any object and rotate it 360 and it'll land on itself. So this has no rotational symmetry. All right, go ahead and try that. And it'll help to take a picture of this to get an idea of what's going on here. And so if I rotate this, there's 90. 90 doesn't map onto itself, but if we rotate it 180, it does map onto itself. So as long as it's 180 degrees or less, it has rotational symmetry. So we're good there. All right. Three-dimensional objects also have different symmetries. They can have reflectional symmetry or rotational symmetry. When they have rotational symmetry, it's rotational symmetry about a line, so you can spin it on that line. And so let's think about that with these here. And when it's drawn on a two-dimensional grid, you really can draw this line and think of it as a plane. And if you split the figure into two congruent halves that are mirror images of each other, then they have reflectional symmetry in a plane. So this definitely has reflectional symmetry in a plane. And then if you can think of a line that you can pierce the object with and spin it, and it maps onto itself, then it also has rotational symmetry. So this, you could definitely do that. Now this one here, I think we could split this down the middle with a plane. So it's really kind of, you're thinking more along the lines of if you cut this object like this, does it map onto itself? And yes, it does. You could also put an object through this, have it come out the end there, a little point, and you could spin it on that line. And so this also has rotational symmetry. So it has both. You can split it with a plane, and you can spin it on a line. So it has reflectional symmetry and rotational. Go ahead, you can try that here. All right, lesson check. Your friend thinks that the regular pentagon in the diagram has 10 lines of symmetry. Explain and correct your friend's error, please. Each line of symmetry bisects an angle of the pentagon. That's good. Each line of symmetry bisects the side of the pentagon. Yeah. Each line of symmetry is parallel to another line of symmetry. No. The pentagon has 10 congruent angles. No. Pentagon has 10 congruent sides. No. Pentagon has 5 congruent angles. Pentagon has 5 lines of symmetry. I think my friend counted twice the lines. All right, that is the lesson. Oh, I guess we could do this quick. So there's one. There is 2. 3. 4. And I'll just use black again here. 5. 5 lines of symmetry. See you tomorrow.